Okay, let's talk a little bit about line structures. So by now you're probably pretty used to drawing Lewis structures, and line structures are essentially just a special type of Lewis structure that we use to draw organic molecules. So in case you didn't know, the term organic means a carbon-based molecule. So a molecule that's based on one or more carbons. And ultimately there's going to be a very specific set of rules that we use to draw these line structures. And the biggest rule is, well, you use lines to draw them. And so if I were to draw this line here, each end of this line is going to be a carbon. So there would be a carbon here, and there would be a carbon here. But in the actual line structure, we wouldn't draw the carbons. They would have to be assumed to be there. And that's because in line structures, every kink, which is a bend, and every end of a line is a carbon. So if you have this just one line here, the two ends of the line would represent two carbons. If we added a kink to this, basically if we added another carbon, that would give us a kink in the structure like this, where now we have three carbons, and this kink right here, where the molecule bends, would also be a carbon. So basically the end of the lines have to be carbons, and the kinks in the lines have to be carbons. And you have to really keep in mind the octet rule. So right now we're showing single bonds between all of these carbons, but we're not showing carbon with a full octet. So you have to keep in mind that these carbons would have hydrogens around them in order to complete their octet. And that's one of the fundamental things with organic chemistry, is knowing that carbon has to have an octet at all times, which means that if you don't see any other elements bonded to that carbon, you have to assume that the octet is being filled with hydrogens. So right here we see a single bond between these two carbons. Well, remember that a single bond is two electrons, so there's two electrons around the carbon, and you have to fill in the rest of them with hydrogens. So 2, 4, 6. The other 6 electrons come from 3 hydrogens bonded to this carbon. For this middle carbon, there would be 2 hydrogens coming off because this middle carbon is single bonded to these 2 carbons. So there's a single bond going to this carbon, there's a single bond going to that carbon. So to fill the octet, we bond it to 2 other hydrogens, giving it the full 8 electrons around it that carbon needs to have. So there's 2 basic forms that your organic molecules are going to take. You're going to have these zigzaggy line structures, and you're going to have these ring structures, which are called cyclic structures. So you'll have rings, and you'll have sort of the zigzaggy structures. And ultimately, when you want to approach these zigzaggy structures, is like I said before, go to the ends of the lines, which would be right here and right here. So we know these 2 things are carbons, and we know each of these kinks has to be a carbon. So there's a carbon here, carbon here, carbon here, and a carbon here. So just count them up. 1, 2, 3, 4, 5, 6. We have 6 carbons here. And so the prefix for 6 is going to be hex. You don't need to know these, I'm just pointing it out. This is something you'll learn if you take organic chemistry. I'm just going to use it as an example for right now. So because there are 6 carbons here, the prefix is hex. And because each of these carbons has a single bond in between it, that's called an alkane. So the suffix is ane. So because they're all single bonds, there's the suffix ane. And because there's 6 carbons in total, it's hexane. And that's how you would name these zigzaggy structures, and that's how you would see these zigzaggy structures named. Versus this ringed guy over here, well, this ringed guy also has 6 carbons. So 1, 2, 3, 4, 5, 6. So this guy also has 6 carbons, and all of the carbons are single bonded to each other. But this one isn't just called hexane, it's called cyclohexane. And the reason it's called cyclohexane is because it's a cyclic structure, because it's a ring. It's going around in a ring structure versus zigzagging up and down in just the regular line structure. So we would call this guy cyclohexane. And there's multiple different cyclos. There's cyclopropane, there's cyclobutane, there's cyclopentane. There's all different types of cyclic ring structures while also having these zigzaggy up and down line structures. So just something to keep in mind when you see these two. This would be a cyclostructure, whereas this would be just a regular line structure. And then you introduce the idea of functional groups. This isn't organic chemistry, so I'm not going to talk much about this at all. But I just want to introduce some basic functional groups to you so you'll be able to recognize them when you see them. So as I said before, when you have a carbon single bonded to another carbon, that molecule is going to be called an alkane. When a carbon is double bonded to another carbon, that's called an alkene. When a carbon is triple bonded to another carbon, that's called an alkyne. This group, so if you see this OH group bonded to a carbon, that's called an alcohol group. So I know you're used to seeing an OH in conjunction with bases, but as a group, it's called an alcohol group. And it's going to make a molecule an alcohol if you see it. If you see an NH2 bonded to a carbon, it's called an amine or an amine, depending on who you are. I've always said amine, although I think technically it's supposed to be pronounced amine. If you have a carbon double bonded to an oxygen, that's called a ketone. If you have a carbon double bonded to oxygen with an H also bonded to that same carbon, that's called an aldehyde. If you have this ring structure with 3 double bonds inside, with 6 carbons in the ring, this is called benzene. Or you'll also sometimes see it drawn like this. The little circle in the middle just means it's aromatic, which this is basically just a lazy way of drawing the ring if you didn't want to draw all the double bonds inside. But this is a very common one you'll see in a lot of different structures, and it's called a benzene ring. When you have an oxygen bonded to 2 different carbons, this is called an ether. And if you have just a carbon with 3 hydrogens bonded to another carbon, this is called a methyl group. And this has different types of names. So if there's 2 carbons, that would be called an ethyl group. If there's 3 carbons, that would be called a propyl group. So it really just depends on how many carbons you have in this addition, but in Gen Chem you'll mostly run into just a methyl group. So these are just some of the common functional groups you'll see when it comes to organic structures. So now if you see these groups, you'll be able to recognize them and understand, oh, this molecule happens to be an alcohol. Oh, this molecule is a benzene. Oh, this is a ketone. So hopefully, you're not going to be tested on this and you won't need to memorize this for Gen Chem, but it's just good to know what to call the molecules when you see them, and it's good to be able to recognize what they actually look like in terms of their name. Okay, now let's do some drawing practice really quick. So let's say you were given this molecule and you were asked to draw the line structure for it. So when you want to draw line structures based on formulas, what I always do is I just want to establish right off the bat how many carbons I have, because that's going to determine what the structure looks like. So let's see, I have 1, 2, 3. So I have 3 carbons. And we know if we're drawing a line structure, each kink or each end is going to be one of those carbons. I also have an OH coming off of it, which, if you know your functional groups, you'll know that this is an alcohol. This particular molecule happens to be called propanol, but that doesn't really matter. It's just an alcohol at the end of the day. So let's start drawing. So we'll start down here and we'll draw up. So this is one carbon here, and this is a carbon here. So I've just drawn 2 carbons. Now I'll go back down. So now I've got 1, 2, 3 carbons. So go back up, and that's where I'll put the OH. So I've got this carbon is that group right there, because remember we got those 3 hydrogens coming off that we don't show, because we don't show when the hydrogens are bonded to the carbon. This carbon is this group here. And again, we don't show those 2 hydrogens coming off. You have to know that they're there. And this carbon is this carbon here, where it's identical to this carbon, except it's just the 3rd one. And then, of course, we have the OH at the end, which is our alcohol functional group that we tack on to that 3rd carbon. So this would be your line structure for this structure up here. So we'll look at one more example, because at that point we're just kind of beating a dead horse if we keep showing structure after structure, because the same pattern applies to any of them. But for this molecule here, let's take a look. So the first thing you want to do, look at how many carbons you have. So I have 1, 2 carbons, and over here at the end I have this this amine group at the very end. So I'll start here with this carbon going to this carbon. So there I have my 2 carbons. This would be the CH3 carbon. This up here would be the CH2 carbon. So now you want to bring it down, and right here is where I'm going to put the NH2 part, because we're showing this bond here going to the NH2. Sometimes I've seen people in the past think that this part right here is a carbon, but remember, this is us showing the bond between this carbon up here and the NH2. So this line part right here is just showing the bond between the 2nd carbon and the nitrogen down here. So right here, this would be our structure, our line structure for this molecule here, and the name of this molecule would be ethylamine, because CH3, CH2 is called an ethyl, and NH2 is amine, so ethylamine would be the name of this molecule. So hopefully now you're a little more comfortable with line structures. Just remember where your carbons are, remember the hydrogens are implicit, which means you don't draw them, and remember the octet rule is crucial. Carbon, oxygen, and nitrogen have to obey the octet rule at all times, so make sure you aren't violating that with your line structures.